Who is talking to me?
Okay. So, yesterday where we left off was with the quotient rule, okay? And so there is the quotient rule as it is officially.
I know it. Okay, I think we know it's red.
Wait.
There's the quotient rule.
I'm still traumatized from that earthquake drill.
Can we not?
Go ahead.
There's the quotient rule as it is officially written, which is the bottom function times the derivative of the top function minus the top function times the derivative of the bottom function over the bottom function squared. But the mnemonic device is
Low D high minus high D low over the square of what's below.
okay, low D high minus high D low over the square of what's below. Okay, so that is the easy way to remember the quotient rule. Okay, and I would say really the most common mistake that students make that I notice is it's minus, not plus. The product rule is plus, the quotient rule is minus. And then also remember you're starting with the bottom function, not the top function. Okay? Yep, so we are going to do a few examples. So let's start with y equals x squared plus x minus 2 over x cubed plus 6. And let's take the derivative using the quotient rule. Okay? Now, some of you will be able to just kind of whip your way through this and you don't need to really think very much. If you like to sort of do a step-by-step thing, here's what I would recommend. It takes an extra 10 seconds to do this, okay? But sometimes it's good to write down low, B low, high, B high, and then you can figure out how to plug them in from there, okay? So the low function is x cubed plus 6. Its derivative is 3x squared. The high function is
X squared plus x minus 2.
and its derivative is
2x plus
2x plus 1. Okay? So that's kind of a way that you can set that up beforehand, so you're only having to think about one thing at a time. As you get better at this, you should be able to just sort of go through it as you go. But this isn't a bad place to start, okay? So now we can just apply the little formula.
X cubed
So
plus
low times
2x plus 1.
b high minus
X squared plus x minus 2.
I b low
This is a little long. Okay. Yeah. Let's just. I don't want to FOIL this.
over the square of what's below. What's that?
X cubed plus 6 squared.
X cubed plus 6 quantity squared.
Okay. So
When you're taking when you want the derivative of two functions that are being divided. Okay?
So like it would be like this all out now.
No, what?
So like our question would be, what is the derivative of y equals?
Right, let y equal that, find y prime.
Uh,
Okay, sorry, I just said, yeah. Okay. Okay, so do we have to FOIL this all out? No, most college math classes, like I said before,
it
except
cancels.
any, well, there's no canceling yet because this subtraction thing is going to screw that up, okay? Most college math classes now, you just type your answer in and they don't care whether you're simplified or not, because what the computer will do is it will take your answer, it'll plug in 2 for x, and it'll plug in 2 to the answer, and if they get the same answer, then you're correct, okay? You know you want to.
What?
You know you want to. FOIL it out. So 2x to the 4th plus x cubed plus 12x plus 6 minus
okay, so hold on, pause.
3x to the 4th minus 3x cubed plus 6x squared all over x cubed plus 6 squared.
Hold on, now stop.
Yeah, no, I know. Who would? All right, then combine like terms. 2x to the fourth minus 3x to the fourth is negative x to the fourth. X cubed minus 3. X cubed minus 3x cubed is negative 2x cubed. Then we have a plus 6x squared. Then we have...
Isn't it x cubed plus 3x cubed?
No, because I did the minus through already. So I went minus x times 3x squared and got negative 3x cubed. Plus 6x squared, plus 12x, plus 6, all over x cubed plus 6 squared. So that's not much prettier than what we had to start with. So what's the point of doing that? All right, this little slide here, what? Yeah, we're just going to leave it like that. This little slide here is really important, okay? The quotient rule is like the worst of all the derivative rules that we're going to learn, okay? So it should only be used as a last-ditch measure. And so there are lots of situations that appear to be the quotient rule that are not, all right? This is a good example of that. You can take 3x squared over x and simplify it to 3x, and then you can subtract your exponents here and change that to 2x to the negative 1. I have seen students do the problem that we worked on yesterday, square root of 10 over x to the 7th, using the quotient rule, okay? Oh yeah, it'll work out. But it's a lot easier to just recognize that this is the square root of 10 times x to the negative 7th and use the power rule, right? You could, yeah, but then the derivative of this is going to be 0, and so a lot of that stuff is just going to cancel out, okay? So you'll get there eventually, but it's a mess, all right? So always think, just in the same way as I warned you when you're doing a limit, don't just immediately start factoring and canceling and multiplying by, stuff. See if you can just substitute in the value first and get the answer that way before you start messing around with all the crazy math, okay? All right, so let's do if y equals 1 over x, then what? I guess we're taking the derivative, yeah? Then we're going to find y prime, okay?
Wait.
It is easy.
Why can you do 1 times x?
Yeah, that's what you should do. So just to know that you are paying attention to that last thing that we were talking about. 1 over x you can rewrite as x to the negative 1. So the derivative is
Negative 1x to the negative second.
negative x to the negative second, which you could also rewrite as 1 or negative 1 over x squared.
That's not even worth
Okay? So again, don't be tricked. And every time you see a fraction thing, I must use quotient rule. Yeah, only if you can't simplify it.
You only use the quotient rule when there's like multiple.
Yeah, right. Floor terms. Exactly. Yeah. Okay. How about the derivative of 6 over t cubed?
6t to the negative.
So we're going to rewrite this as 6t to the negative 3. So that's, which we could also write as, okay?
What is t over dt?
You're going to have to eventually, yes. So I'm just trying to review with you the negative exponent rule so you can get easy with that. What did you say, Leanne?
Does the d over dt mean find the derivative?
Yep, the d over dt means
So
minus.
sometimes they want you to write it the second way, or does it matter? Does it matter?
Sometimes you're going to write it like this,
Why?
okay? Because they might say, what's the domain of the derivative?
Oh,
And then you need to rewrite it like this so you can say it can't be 0. Right. Or they say, find where this has a horizontal tangent. And so you have to set it equal to 0, and so then you have to, all right? So you need to just get good at negative exponents, okay? Ooh, how about this? If f of x is equal to x to the pi, what is f prime of x?
Ix to the x pi minus 1.
Can't trick you guys, can I? Yeah, it's the same thing. Pi is a constant, okay? It's not a variable. It's just a number. So you put that in front, subtract 1 from it, that's your new exponent. Cool, okay? So don't be all
So
freaked
you
out.
should leave it as pi minus 1, not 2.14.
Right, because then you'd be rounding. And that wouldn't be exact anymore. All right, so let's try another one. Let's let y equal 1 over 3 times, or the cube root of x squared,
So
and let's
one-
find the derivative of that.
1 times x to the 2 over 3.
Okay, yeah, I'm going to do this in 2 steps. First of all, get the square or the root thing into fractional exponent notation. So that's really 1 over x to the 2/3. And then we can rewrite that as
X to the negative
x to the
2/3.
negative 2/3. And now that we have it written like that, we can take the derivative.
Negative 2/3 x to the negative 5 over 3.
Okay, which if we wanted to, just to practice this.
2/3 over x to the 5 over 3.
So that.
Yeah, that's good.
Not good?
Or,
Because the 3 is
or the 5th root of x.
Oh, nice, okay. 3rd root actually, but yeah.
3rd
I'll go
root
with
of
that.
x to the 5th.
This would be 3 times the cube root of x to the 5th.
Or you can put the negative on the bottom.
Okay, yeah, all right, so we got a lot of different things going there. Okay, so we okay with that?
Yeah.
No?
Only 26
Yeah.
more minutes. Of fun.
26 more minutes of fun. Okay, so let's try differentiating the function f of t equals the square root of t
This is
times
the thing we
a
did
plus
yesterday.
dt. Yeah, now, when you look at that, what you have to do is you have to identify which is the variable and which are the constants. Which is the variable and
T.
how do you know? How do you know?
Because it's used more than once.
Okay, that's a good, like, sort of
And
rule of
it's
thumb.
f of t.
But yeah, it's f of t, right, so it's telling you that f is a function of the variable t, okay? So the first thing that I'm going
Hang on, I
to
want to
do,
write this one down.
okay, the first thing that I'm going to do is I'm going to rewrite that once again with a exponent instead of using the square root symbol. And then in this case, what do we do?
Hang
We're going to
on.
have to do the product rule. The product rule. How long
It's
with
for
you? I don't want to. You want to be on YouTube? You want to make a?
Yeah.
Okay, so now we're going to take the.
1d2 minus plus 2.
Slow down, Ray. Slow down. Did you say wait? And you guys have a question? Yeah.
Yeah,
Go ahead.
Why can't we just distribute?
Great question. Why can't we just distribute?
But
Why can't we just distribute?
because you have to find the derivative.
No, she's 100% correct. We could do it. This is just like the quotient rule and the other ones we were talking about. You can do it either way. So if you feel like that's
No,
going to
we're
be the
gonna
easier
use
way.
it.
I thought we were too, but Gabby shot us down.
Can
So
we do the product rule then?
we'll do both, and we'll see that it comes out to be the same answer no matter how you do it. So if Gabby wants to distribute this t to the 1/2, t to the 1/2 times a is obviously going to be a t to the 1/2. What is t to the 1/2 times bt? Ooh, that's a simple. bt to the 3/2, yeah. Because remember, when the bases are the same, what do you do with the exponent? You add them, okay? So yeah, that's a great observation, Gabby. That's another way we can do this problem. But you're freaking Taylor out, because we already said we were going to do the product rule, so we're going to keep going with that. Okay? Yeah, I like your way, but I also appreciate Taylor's educational needs, so we'll do it both ways.
Change up in the middle.
You can't change up in the middle. We said product rule. It's on tape. We can go back, we can watch it. We're committed to the product
Did you
rule.
start recording
Okay.
again?
I did, yeah. I thought he was going to come in and talk to me, but
Trish is
well,
not gonna watch it.
she does. Okay, so product rule, especially for Trish and Christian because they were going yesterday. So what do we do?
1d2 minus
Okay.
2 plus 2d1.
1d2 plus 2d1. And Mr. Pugh's going, what is this, a math class or something? Okay, so 1 is the first function, t to the 1/2. d2, what is the derivative of the second function? Nope, nope, close, nope. What?
1.
A
Nope,
minus 1.
nope.
1t.
Marcella, can you save us?
I said
No.
1t.
Okay.
What is
Nope, closer.
1 plus
What?
t.
B, good. Why is it B? Why is it B? Shh. Why is it B?
Coefficient of the variable.
Because it's the coefficient of the variable. This is a constant, so its derivative is 0, okay? This is the coefficient of the variable, so essentially that would be aligned with the slope of b, right? And so it's just going to be b.
I like that.
Okay. Now you want to switch?
Yeah.
I don't like this.
Okay, think of it like this, Blue. Think of it like this. A and B are numbers, right? So what is the derivative?
Okay, so number 0.
Right.
No.
What is the derivative of 3 plus 2t? That's 2. So if it's a plus bt, then it's just going to be b. Okay?
Yeah.
All right. So that was the first one times the derivative of the second one plus
A plus B two.
the second one, which is a plus bt times the derivative of the first, which is
1/2 t.
to the
-1/2.
negative 1/2. Okay? And you could kind of leave it like that, but we are going to simplify it a little bit. Okay? Because we want to compare to the answer that we get when we do it the easy way here, and then hopefully you'll all understand that Gabby is right. So this is bt to the 1/2.
Yeah, I got
Okay?
Plus
Plus.
u.
Oh, do we have?
So we're going to end up distributing anyway, right? So a times 1/2 t to the negative 1/2 is half a times t to the negative 1/2. Okay? Plus
Half.
1/2 b t to the
1/2.
also 1/2. Okay?
No wait,
Why is it not?
no the first. Yeah,
Because
the
this
first
has the
one's
power
negative.
of 1, right? And so if you add the exponents, 1 plus negative 1/2 is
Oh my
positive.
gosh, and if you add.
Okay?
This is awful. Pull a t out.
Okay, no, we have two like terms here.
Well, t to
bt to the
1/2.
1/2, bt to the 1/2. So if I have a full bt to the 1/2 and I have half a bt to the 1/2, how many bt's to the 1/2 do I have?
1.5.
1.5. So
So
that is 3 halves, good. bt to the 1/2 plus 1/2 at to the negative 1/2. And that is our final answer. Okay? Can you see now
Yes.
that if we did it Gabby's way, we would have gone directly from here to here, because put the 1/2 in front gives you 1/2 at to
Now
the
you're so
negative
smart.
1/2. Put the 3 halves in front, okay? So moral of the story, and then Gabe, I'll answer your question. Moral of the story is with all these problems, simplify as much as you can before you start doing the calculus, okay? Gabe,
So that is like the second line.
this line right here,
Yeah,
okay?
that's the derivative.
This is the
I feel
derivative.
like you were just simplifying.
Yeah.
We were, that's correct. Yeah. So once again, the calculus is easy. The algebra is challenging. Okay? All right, so let's,
We just like go and sit in algebra.
yeah, just to learn that,
Yeah, just to
really mostly advanced algebra, yeah. Okay, so differentiation rules enable us to find tangent lines without having to resort to the definition of a derivative, right? So that's nice, yeah. We have these formulas now. They also enable us to find normal lines. Have you ever heard that word before? Not in a...
Right angle.
Yeah, I don't know why this switches in calculus, but all of a sudden they start using the word normal
Nothing
instead
is
of perpendicular. Okay? So if you have not seen that before, that's what that's all about. A normal line is a perpendicular line. Okay? In the study of optics, one needs to consider the angle between a light ray and the normal line to the lens, for example. Of course. Okay? Yeah. If you ever wanted to know when you might use this. So normal means perpendicular, and that's handy because what's the relationship between the slope of a line and the slope of the
Opposite.
line perpendicular to it? What?
They're negative reciprocals.
Right, negative reciprocals or opposite reciprocals, okay? So remember that. So perpendicular lines have slopes that are opposite reciprocals. Okay, so for example, let's go both ways here. Let's figure out the equation for the tangent line and the normal line while we're at it. To the curve, square root of x over 1 plus x squared at the point 1 comma 1/2. Yes, ma'am.
Okay, so now we're finding the normal line to the what? To the normal.
Okay, so this is the graph, right? I don't know what it looks like.
And
Looks
then you
like
would
that.
just use point slope.
Okay. Good. 1/2 is this point right here. Okay. That point right here, there has a tangent line. So we're finding the equation for that tangent line. Okay. It also has a line that is perpendicular to that tangent line.
Okay,
So we're
so the
finding
normal
a
line.
Got it? Okay, so we're tangent at that point and perpendicular at that point. Okay? Okay, so like I said, 95% of the questions that I ask you between now and Christmas, the answer is the same. What do we do first? Find the derivative. Okay, so we're going to take y equals, I'm going to rewrite this in exponent notation right off the bat. Y equals x to the 1/2 over 1 plus x squared, and take the derivative of that. And why don't you do that part on your own, and then we will compare our answers and make sure that you are doing this. Okay, so what do you guys get?
I just got the low half part.
That's fine.
Half x to the negative 1/2. No, negative 1/2.
What?
What?
We had an
Wait, is
earthquake.
that right?
Oh,
It is 1/2 minus 2 over 2.
Wait, I got 1 plus x squared. Yeah, and then half x squared.
I got 1/2 to the negative.
Yep.
I got half x
It's
to the negative
negative.
1/2.
There you go.
Hey, that's what I got.
That's what I got.
And then positive.
That's what I got.
Wait. I thought we were. Why is there a 2x at the end?
Because that's high b low.
Wait,
The derivative of the low, 2x.
Oh, it's getting that part.
Okay? Okay, but we're not done because now we're actually going to use this derivative to figure out a problem. What are we going to use this for?
Our slope.
Right, we're going to find the slope at
It's a
1.
terrible slope. Oh, you just
Okay.
plug 1 in.
So we're going to plug in 1. And 1 is a really convenient number to plug in because of all these square roots. It's going to just still be 1. So that gives me 2. That gives me 1/2. That gives me yeah, because that's the x value of the point at which we would like to
And
take
then
the
you do
derivative.
point slope.
And then I would do point slope form because now I feel like the problem is pretty much done.
So
You
what
can
does
if you
negative
want.
1/4 equal?
That's the slope of the tangent line at this point.
That.
It helps us find the equation for the tangent line because now we can go y minus 1/2 equals the slope times x minus 1. Okay, so this is the equation for the tangent line.
And then to do the normal, you just, it's 4. We did this in geometry.
Yeah.
Cool.
Okay? I want to make sure everybody's okay with that, with what just happened.
Yeah, I just went through and simplified.
Yikes.
That's fine, we can do that.
Well, that just kind of wastes time.
Well, if you're
Only playing in a point.
Yeah, true, if you're only plugging a point, you're just probably more likely to make an algebra mistake when you do that. So,
wait, what did you do?
she simplified the derivative from here, she did some algebra from here.
Yeah, it really was.
Cool, tell me what.
When? No, wait. When have you not? Everything is valid.
Yeah, just because you're a princess.
I just know it is. I say that.
There,
Yeah, because
Bill.
I said no.
Okay, so let's try another one.
I knowed everything.
Let's try another one. This one says at what points on the hyperbola,
What's the hyperbola again?
it's the,
Okay.
at what point on the hyperbola xy equals 12 is the tangent line parallel to the line 3x plus y equals 0? So parallel lines have
The slope has to be 3.
same slopes, right? Close but not quite. 3x plus y equals 0 means my slope is negative 3 because I have to
yeah.
solve that for y. So I need to figure out when does the tangent line have a
Okay.
value of negative
Can I write this
3.
problem down?
Uh-huh. Okay, so let's wrap this up real quick. So xy equals 12. In order for us to take the derivative at this point, we will learn later on in the class a way to take derivatives of functions that have x's and y's together, but right now we need to solve that for y. So I just divided both sides by x, okay?
Y equals 12.
So I'm good. So let's rewrite that as 12x to the negative 1. And so the derivative of that is negative 12x to the negative 2.
And then don't you plug in negative 3?
I do not plug in negative 3. No. What do I do?
You substitute?
What did you do
Nope.
to Y?
You
Nope.
said that equal.
I set it equal to negative
what I
3
meant.
because I want to know when is that parallel.
But
So I need to know when does the derivative equal negative 3. So this is a prime example of what I was talking about before when I was switching these back to positive exponents. In order to be able to solve this, you need to change that into a positive exponent. So I need to rewrite this as negative 12 over x squared equals negative 3.
Wait, why is it?
Because I can't do algebra with a negative 2 as an exponent. I don't know.
Can you just,
Right? Now I'm going to do the old switcheroo.
Oh, boy.
If negative 12 over x squared equals negative 3, yeah, then I know that negative 12 over negative 3 equals x
isn't it plus or
squared.
minus 2?
Okay? Yes, it will be. Okay? I can always take these two things and switch them through basically cross multiplying. So that means x squared
X
equals
equals 5.
4, which means that x equals plus or minus 2. Okay? That's why it's set at what points on the hyperbola. So one of the points is 2, 6, and the other point is negative 2, negative 6.
You just plug that in real fast.
I did,
Where?
yes. To the original equation, I think.
Oh.
So 2 times 1 is 12 is what I... Okay? All right, so to summarize, in case you missed it, here are all the derivative formulas that we learned in this very important section. Okay? The derivative of a number is 0. We learned the power rule. We learned that you can add the derivatives together, subtract them, and then we use the product rule and the quotient rule. Yes?
Why is the derivative of 0? You know what's
Because the derivative
Yeah, it's slow.
of the function, right?
If you do it with like the half of it, it doesn't make sense.
Oh, yeah, it does.
2 to the first half. It's something times x to the 0.
When I'm taking the derivative of f of x equals 2, I'm not doing 2 to the first power and then using the power rule from that. I'm doing 2 times x to the 0. Because you're always taking the derivative with a variable. So now if you put the 0 in front, gone.
Okay,
Okay?
I have a question. Why isn't that thing we did yesterday where you like do the, it was on the worksheet where you do the weird thing?
Oh, we're not there yet. That's the chain rule. We're not there yet.
Oh, okay.
Okay, we'll get that later.
I like the
Okay.
chain rule, but. That's not.
Only
like,
9 problems?